everyone, I'm Alexis Heraclis, and today we'll be talking about point mutations. Before we get started, I'd like for you to pause the video to review some terms you'll need to know on the topic. Here we have our original DNA sequence that we'll be working with throughout the video. In relation to this DNA sequence, we're posed with the task of transcribing and translating this original sequence to get a 5-amino acid protein chain. Let's get started. Our first step is determining which strand of the DNA is the template strand and which is the coding strand. This is important because the coding strand is what's transcribed into the mRNA sequence. We'll begin by first reversing the bottom strand so that it is in the 5 to 3 direction and reads left to right. Once that's done, we can see that both the top and bottom strand should have the start codon AUG, with thymine T being changed to uracil U in the mRNA transcription. Although since we're looking for a 5-amino acid chain, the stop codon, as seen underlined, should be 5 codons down from the start codon. This is seen in the bottom strand but not the top strand, making it our coding strand. Now that we have our coding strand, we can transcribe the DNA sequence into the proper mRNA sequence by replacing the base thymine T with the base uracil U, and this is what we get. We can now move on to translation, where we take our mRNA sequence and use the color-coded codons, say that 3 times fast, to translate them into our 5-amino acid sequence. Using the chart in the bottom right, our amino acid products are methionine, valine, arginine, phenylalanine, and lysine, with our stop codon being UAA. Let's apply all that we've learned and move on to some examples of point mutations. In our first example problem, we have our original coding strand with the amino acid products it codes for beneath it, and our mutant strand that contains a point mutation for us to find. Our tasks are listed below. We must find the point mutation, determine if it's a transition or transversion, and what type of consequence comes from it. Pause now to try it for yourself. As you can see, our point mutation is the thymine in our coding strand is changed to an adenine. This is a transversion mutation as the ring structure is changing from a pyrimidine to a purine. The consequence of this is that it encodes for a different amino acid, making it a missense mutation. Continuing on to our next example, pause the video and repeat the previous steps to find the answer. Okay, so our new point mutation is from a cytosine to a thymine. This is a transition mutation because it stays within the same ring structure, pyrimidine. The consequence of this is null and void because it encodes for the same amino acid, making it a silent mutation. Pause the video now to answer problem number 3. This point mutation is a change in adenine to thymine, and as previously mentioned, this is a type of transversion mutation. The consequence of this is that the amino acid lysine is changed into the stop codon UAG, which ends transcription and makes this a nonsense mutation. Now try your hand at our last example. As you probably found, our last point mutation is a transition mutation from a thymine to a cytosine. The consequence of this is that our stop codon TAA, or UAA, is changed into the amino acid glutamine. This means the amino acid chain doesn't stop but continues growing, making it a read-through mutation. That concludes this video. I hope you learned a thing or two about mutations, and thanks for watching.